In this problem, we're asked to solve the integral of sine evaluated at the square root of 2x plus 1. And if you try to do this integral just using integration by parts, you would actually get stuck very quickly. The basic idea is if you tried that, you would have to let u be the sine of the square root of 2x plus 1. And when you're calculating du, you would have to do its derivative. And when you do its derivative, you need to do the chain rule, and it leads to an even more complicated expression than you started with. So this problem is actually an example where you have to use the method of substitution before you apply integration by parts. So I'm going to go ahead and let t equal the square root of 2x plus 1. The reason I'm using t instead of the more common substitution of u is that I'm going to want to use the letter u when I do integration of parts later. The square root of 2x plus 1, of course, is the same as, square rooting is the same as having a 1/2 power. And once you know t, we need to figure out what dt is equal to. So we're going to need to take the derivative of this expression. And when you do the derivative of 2x plus 1 raised to the 1/2 power, you need to use the chain rule. So multiply by the original power, 1/2, decrease the power by 1, 1/2 minus 1 is negative 1/2. But then I need to remember to multiply by the derivative of the inner function. And the derivative of 2x plus 1 gives me this extra factor of 2. So now we have a relationship between our differentials dt and dx. We can simplify this expression because there's a 1/2 multiplying a factor of 2. So those are just going to cancel. Now I want to solve for dx because I'm going to replace this dx with whatever expression I get. And to do that, when I have this expression with the negative power, it's the same as if I were dividing by this expression with a positive power. So basically, I'm going to multiply this factor over to the other side to isolate dx. Okay, so I multiplied by this. You can think of it as multiplying both sides by 2x plus 1 to the 1/2 power. And that gets me this expression for dx. However, if I just started replacing things now, I'd get stuck because I would have sine of t, and then I would have an expression that still involves x. So I need to make one more observation, which is that this expression that I have right here, the 2x plus 1 to the 1/2 power, that is exactly the same expression that I had for t. So I can replace it with t, and now I can rewrite dx as just t times dt. Now I'll actually be able to rewrite my entire integral in terms of t and integrate it with respect to t. To do that, I need to see what I can replace. So I can replace the argument of the sine with t. That's how we chose t to begin with. And we can replace dx with t times dt. So I make those two replacements. And last, I'm just going to rearrange this expression a bit. I'm going to make it look a little bit cleaner by bringing the t out front and dropping these unnecessary parentheses. So now, instead of this integral that we started with, we have an equivalent integral, one that looks a lot more like things that we've done the integration by parts method on. And so now we're going to use integration by parts to evaluate this integral. So we're integrating t times sine of t. This should say dt, not dx. And we need to start by figuring out what we're going to set u equal to in the integration by parts method. So the first function type from our list is algebraic. There's a factor of t here that appears before trig functions. So we're going to let u equal t. And next, that means dv has to be everything else inside the integral. In this case, that means dv is sine of t times dt. Now that we have u and dv, it's time to find du and v. Du is going to be the same as dt because u is equal to t. And to find v, we need to integrate. When we integrate sine of t, we get negative cosine of t. So now we have everything that we need to plug into the integration by parts formula. Let's go ahead and do that. U is t. Both of these v's are negative cosine. And du is dt. As usual, after I plug everything in, I'm going to look for things to simplify. In particular, I see a minus minus, and they combine to plus. I also move this minus sign out front. Next, we have this new simpler integral, the integral of cosine of t. That is just one of our basic integrals. Evaluating that, we get a sine of t. So now I kind of have the answer. I have the answer in terms of t. T was a variable that we introduced to make progress in the problem, but our original variable was x. So we need to rewrite our answer in terms of x. And to do that, we need to replace all these t's with the original substitution that we made, which was the square root of 2x plus 1. So that's the last thing we do. Replace each of these factors of t with the square root of 2x plus 1. That gives the final expression. This is equal to the integral that we started with.